Kenny, is it recording okay? It threw an error here. We're good? Okay. Hi, everyone. This is Rob. I just want to let everyone know we'll be starting the webinar in about 2 minutes. Thank you all for attending today. Really excited about having this great presentation from Mark. So just hold on. We're going to let everybody join us in the next minute or two, and then we'll start up at 1 p.m. I'm going to say Central Standard Time or whatever time frame you're in, top of the hour. Thank you. Hi, everyone. I'd like to welcome everyone to the Data Architecture Virtual Chapter. My name is Rob Canzaneri, and I'm really glad you're here today. We're really excited. We have Mark. He's going to give a great presentation. If anyone would like to speak in the future, or anyone would like to email me or Kenny, you can obviously get me at rob@sqltigers.com. So let's go to the next slide. So upcoming webinars. We're going to have 2 more webinars that are planned as of now. Well, we have a lot of webinars, but here's 2 of our upcoming webinars. One's going to be by Jonathan, and one's going to be by Glenn. I hope you all sign up. They're going to be great. We'd like to thank our sponsor, HVR. They're just a great sponsor for the group. Can't say enough good things about them. There's a link at the bottom of the screen. Please check out their software. It's great stuff, hvr-software.com. And our other great sponsor we have is Nutanix, and we have a bit.ly link down there for Nutanix. If you have an opportunity, check out their website too. They have some good software too, great software. Thank you, Nutanix. Thank you, HVR, for being our sponsors. Summit's coming up, and as always, we have a really big discount code of $150 off. When you go to sign up for Summit, please use our discount code. It actually, if enough people use the discount code, we can maybe give away a some free session or something to Summit this year. It'd be kind of cool to have just a session dedicated to Pass and give away a session based on people using our code. They're also looking for speakers. So there's a call out for speakers. So if you want to speak, the link at the bottom, you can speak for Pass. Pass is celebrating 20 years, and they have a whole bunch of events coming up. So if you have, you can log into SQL Pass and check them out. Once again, upcoming webinars. So there are a lot of virtual chapters out there. A lot have a lot of great topics. So here are a few coming up, and I'm going to go to the next slide here. If you have time, you may want to check out some of these, different webinars. You can see Paul Randall's talking and Grant Fritchie, just to name a few. We go on and on and on. It's amazing the community, how they have great speakers, and there's no charge ever to see these webinars. Here's a couple more here. And look, here's ours at April 10th. And we'll have Jonathan. So please check out ours too. Okay, upcoming SQL Saturdays. So obviously PASS really promotes a lot of SQL Server topics, and SQL Saturday is just a great event to learn more about SQL Server. So if you're in an area, or you can attend, like say Boston or Richmond or Tampa or wherever, these are the events upcoming. You can see that all over the world they have events, and great training for no price at all. It's amazing. So with that, I'd like to welcome Mark today. Mark, can you hear me?
I certainly can, Robert. Good day.
Well, thank you for coming on. This is great. I'm excited to have you today. I'm going to make you the presenter right now.
And I will use this opportunity to show my screen.
Yeah, I see it perfect. Thank you.
All right. Good morning, good afternoon, good evening, everyone, and welcome to today's presentation. As Robert said, my name is Mark van der Wiel. I'm CTO at HVR. HVR, of course, we're one of the sponsors. We provide real-time data integration technology, data replication techniques for heterogeneous environments. And what we're going to talk about today is how we can utilize just our technology in general, but generally data integration onto Azure. I'm sure that's a topic that is coming up a lot in your organizations. And I wanted to talk about some best practices to consider as you're moving data onto Azure. So what I'll be talking about today is, first of all, a few slides to introduce the topic of cloud adoption. Then we'll go into the 3 tips, and we'll explain and clarify why we would recommend these particular tips. I'll then dive into a very quick demo, and then there is room for questions and answers along the way, but certainly at the end. If you have any questions, please do use the Q&A panel in the GoToWebinar control panel. That's where you can ask your questions. If you have questions throughout the webinar, throughout the presentation, please do feel free to submit your questions, and then Robert will do an honest effort to interrupt me to ask the question when it's relevant. Otherwise, we will certainly get to your questions, hopefully, at the end of the session. So with all of that said, let's talk a little bit about cloud adoption. So the cloud is a very hot topic. In fact, according to Forrester, in a recent publication, they indicated that 60% of North American enterprises rely on public cloud in one way or the other. Now, of course, there's multiple ways of leveraging public cloud. One way, of course, as we probably all do one way or the other, including ourselves, we utilize Azure, right? We use virtual machines on Azure. We use SQL databases on Azure. Maybe we use SQL Data Warehouse. Maybe we use the Azure Data Lake Store. Maybe we use blob storage. There's a lot of technologies. There's a lot of capabilities available in the public cloud like Azure. But there's other ways in which we potentially rely on public cloud. Maybe, again, like ourselves, maybe your expense system resides in the public cloud. Maybe you're using technologies from a cloud provider, Microsoft or others, to run your CRM system. Maybe you have a support system that is hosted in the cloud. But anyway, so 60% of North American enterprises, one way or the other, rely on the public cloud. Now that's interesting, but what's arguably almost more interesting is that 88% of organizations that are using the cloud today, which is, like I said in the previous slide, 60% of North American companies, they would apply a cloud-first approach when they retire on-premises systems. So that means that even though you may not be using a lot of cloud today, or just generally organizations may be using only a little bit of public cloud today, they will be using a lot more because, of course, over the next few years, a lot of on-premises systems will retire depending on your organization, you may retire systems in 3, 5, maybe 7 years. But in any case, those systems are going to retire, and your organization is more likely than not to use a cloud first attitude or apply a cloud first approach when those systems will be retired. Now then, if we look at Azure's growth, so per the most recent Microsoft annual report back in January, Azure was growing 76% year over year. So that's, of course, a very respectable growth and very exciting for this community, very exciting just generally for data integration, data management experts like we all are. So with that, let's just dive into the 3 tips that I wanted to share today for adopting or moving data onto Azure. So the first tip is actually related to your data, right? Because your data is arguably one of the most important assets of your organization, and well, exposing it could be an extremely bad liability for your organization, and that's where, well, and this monster comes in. The monster might be looking out to compromise your data, and arguably the very last thing you want is for your data to be compromised. We hear a lot of scandals in the news about data getting compromised, whether it's at a credit card company or a store or store chain. It doesn't matter where the data gets compromised. It's always really bad for the organization, really bad news, really bad publicity when data gets exposed, gets into the hands of the wrong users, or gets into the hands of oftentimes they don't even know who the users are, who the consumers are, but then data gets exposed is a bad situation. So what you want to do, of course, for your users is secure your data. So that monster is going to be unhappy because the monster can't get at the data that it wants. So how are you going to do that? So first of all, you want to lock down the firewalls as much as you can. Whether you're running dominantly in the cloud, or whether whether data maybe also resides in on-premises data systems, you always want to lock down the firewall. If you're already in Azure and you set up your connectivity in Azure in a way that the Azure services can connect to your environment, well, then you don't even need to open up the firewall to the outside world. So utilize that approach if at all you can. If you come out of on-premises, well, you'll need to open up the firewall one way or the other. And of course, Azure has very fine-grained capabilities of opening up the firewalls. Open it up as little as you can. Only open up the port that you need. Only open it up for the source where the data comes from. Don't just open it up to the world, to everybody, or even everybody potentially within the organization. No, only for the environment where it comes from. And of course, Azure helps you there by indicating how it sees your environment when you log on to the system, as what network identifier. So locking down the firewall is absolutely important. That's not only into Azure, of course, and arguably almost more importantly, you also want to make sure you lock down the firewall to your on-premises data center, and maybe you have network administrators or systems administrators that want to ensure that there's no holes in the firewall into the on-premises systems, because whilst Microsoft have very strong capabilities and expertise in managing firewalls and making sure that data in Azure doesn't get compromised, of course, when there's still data outside of Azure, you have to worry about it as well. So a second aspect of securing your data, so still related to the vulnerability of your data, is making sure that you use strong authentication. Because, of course, as an outsider, someone might try to break into your system. Maybe they find a hole in the firewall. Well, if that's the case, they may try to log on to your system to see if they can access the data. Using strong authentication is, well, another way to prevent people from getting access, to prevent hackers from getting access to your systems. Use two-factor authentication if at all you can. Use both a combination of a username password as well as a certificate, and both have to match in order to get in. Things like that are just generally best practices, and we probably all come across these best practices as we log on to various online systems. Some organizations, maybe your bank, will nowadays require you dual-factor authentication. They'll send you a text message every time you try to log on as a secondary means of knowing that you are the person who knows the password to that particular account. So using strong authentication is definitely part of securing your data. And then, of course, encrypting data that's on the wire. It's very important, especially when data moves between data centers, and in the end, when you send it into Azure, you send it into the cloud, but at the end of the day, fundamentally, you send it into another data center. It's just operated by Microsoft in this case. When data goes across the wire, it must be encrypted. There's no question about it anymore. If you send any organization's data across the wire encrypted, your organization may store data from some other organization. Maybe you're an ISV. You must ensure that that data is unreadable, not understandable when it's on the wire. So when the data monster comes in with his vacuum cleaner, he can maybe grab the bits and bytes, but he or she wouldn't be able to make any sense out of it because the data is encrypted and they wouldn't have the encryption key. So that's important. Encrypt your data. Use a strong encryption algorithm, something that's AES 256 kind of secure or more secure. And then lastly, encrypting your data storage, right? So even though your data goes into Azure, and of course, Microsoft will do its best to ensure that it's not going to be exposed, it certainly doesn't harm to encrypt it. Yes, it's going to cost a little bit more because you're going to need to use system resources to encrypt your data, but at the end of the day, it's a better safe than sorry. Encrypt your data on the destination as well, and Azure certainly has a rich feature set there that you can take advantage of. So tip number one, secure your data, lock down your firewalls, use strong authentication, encrypt your data, both when it's on the wire as well as when it resides in the final storage location. Second recommendation or second tip, optimize your data transfer. Transfer as little data as you can, right? Makes sense. When we transfer data between data centers, that can potentially be costly. We want to make sure that we make the most out of our data transfer, and any data that we don't have to transfer, of course, how about we don't transfer it, right? So we start on, as part of this, use change data capture. That's what CDC stands for. You identify what the changes are on one side, and then you only send across the changes, right? If we're using SQL Server, we all know that the changes get written to the transaction log, the T-log. So how about we go and identify based on what goes into the T-log what the changes are. So instead of sending the entire data set over and over again, we might have terabytes, tens of terabytes, even hundreds of terabytes sitting in our databases. How about instead of sending the entire data set each time, we only send the changes? Of course, there's going to be a one-time load, and that's unavoidable. And well, Azure certainly has a lot of ways of getting the initial data loaded. But then on an ongoing basis, to keep systems in sync, how about we just do change data capture, identify the changes, and only send the changes across? That's certainly a good way of reducing the data transfer, especially if you have a very large current data set. Then secondly, how about we compress the data, right? We're going to be sending, let's say, 10 gigabytes every hour. Well, if that 10 gigabytes was compressed by a factor of 5, then instead of sending 10 gigabytes, we're actually sending 50 gigabytes of data. Of course, we're still sending 10 gigabytes, but at that point, that data is compressed. It's smaller than it otherwise would be. So we almost magnify the bandwidth. We utilize we make better use of the network bandwidth that we actually use. So compressing it before we send it across the wire is actually a good idea. And then lastly, we still want to maximize the bandwidth, right? Because maybe we are in a situation that we're going to do an initial data load. We want to send the entire data set. Well, if that's the case, then certainly we want to make sure that we could do this as quickly as possible. Maybe you dedicate a weekend to do your initial load, and let's say you have a 20 terabyte database. Well, then you can do the math of how much data you want to be sending every minute, every second, and you want to be able that the technology you use can maximize the bandwidth. Now, again, even for the initial load, you want to, of course, apply compression, because if you're going to be sending a terabyte of bytes across the wire anyway, you might as well have 10 terabytes of data actually sent across the wire rather than just 1 terabyte. But maximizing the bandwidth is certainly one capability that you want, in addition to, of course, those other best practices, those tips to optimize the data transfer. So start with change data capture, find out the bare minimum of the changes that you want to send across. If your database has 1,000 tables, but you're only interested in the data for 100 tables to create your data lake in Azure, well, then only get the changes for the 100 tables, not for all 1,000. Do your change data capture on the source. Before you send the data, compress it, right? Of course, we also encrypt it. That's, of course, from an optimization perspective, that's arguably redundant. That's a must-have from a security perspective. So we compress the data, then encrypt it, but then we want to be able to maximize the bandwidth for those cases where we need it. Maybe there's a large batch load. Maybe there is the initial data load that needs to happen. All right, over to tip number 3, validate your data. Because there is your business user in the center of the screen, and that business user looks a little confused or looks a little sad, right? That business user doesn't know whether they can rely on the data that you've pushed into the data lake or into the data warehouse. Are those data sets identical? I'm just about to walk into a meeting with my boss, and I need to present these numbers. Are these the right numbers? Can I trust the data? And how are you going to build trust with your business user? Well, the answer is you validate your data. Why would you validate your data? Of course, if we consider a very common scenario, a scenario that we come across a lot, is on-premises sources, destination in the cloud. Maybe the use case is a migration. You're trying to switch off some of the Oracle databases that are running in your own data center, and you want to move to Azure SQL databases. Well, how about you validate the data before you press the button that everybody is now going to be using the Azure SQL database, right? You lower the migration risk. You avoid a situation that maybe a month down the line, a business user would come by and say, look, I used to have access to this data a month ago, just before we migrated to Azure. I can't find the data anymore. Where is it? Right? Validating the data programmatically is just a very good idea, just to ensure that your data is correct, is accurate before you migrate your data. But likewise, also building end user trust. Right? Maybe your organization is running databases of various kinds. Maybe there's some DB2 in the mix. Maybe there's Postgres, there's MySQL, there's Oracle, there is SQL Server as well. And then in the end, you're feeding all of that data into an Azure SQL data warehouse. Comes out of a variety of different sources, goes into one destination. It's a consolidated data set, and business users are meant to use that destination system in order to run their BI queries. How do they know that the data set is current, accurate, and exactly identical to what was in the source? Well, again, they need to trust their data store. They need to have confidence that the data that they're looking at is correct. So validating your data programmatically is a way to build that trust. If you can show on a regular basis that those systems are in sync, the first couple of weeks, the business users might wonder, but then in the end, they're going to be very happy. So to summarize, how to get to a happy business user and a discouraged data monster, first and foremost, secure your data. You want to make sure that your data is always secure, doesn't get compromised. You don't want your organization to be in the news because there was some data breach. You want to optimize the data transfer. That's from a cost perspective, just generally a good approach. But secondarily, it also allows you to lower the latency. It also allows you to keep the data closer in sync when you optimize the data transfer. And then lastly, but by no means least, validate your data. Make sure that before you migrate systems across, that the data is accurate. It's identical between what was the old source and what's going to be the new source. And maybe for some time you want to send data in the reverse direction and continue to validate it to make sure that the data remains in sync, and eventually you can complete the migration and switch over to the new system. But arguably, it's almost more important, especially in heterogeneous environments, to validate your data on an ongoing basis, just to make sure that your business users can trust the data, that they are the happy campers, like this gentleman who is on the slide right here. So what I'd like to do next is show you a quick demo of the HER technology where those best practices are in place. Now, before I show you the tool, let's first focus on the scenario. And the scenario is an Oracle on-premises database. It's in fact sitting right here on my laptop. And we're going into an Azure SQL database. So what's running on my machine on the left-hand side is an Oracle 12c database. It's running inside a virtual machine on Linux. And I have HER installed on that machine. And then we have HER Hub running on my local host on Windows. The HER Hub makes a connection to a repository. That repository resides in SQL Server in my environment. And then as we send data into Azure, we're sending it across the wire, encrypted, using HER's encryption, because we're also using an HER installation in Azure in the same region, in the same US West 2 location as where the destination database lives, and then from there we apply it to the database that's right there. Now the slide says Data Lake Store, and I didn't notice that until we just got there. It's an Azure SQL database. It's not the Azure Data Lake Store in this example. So let me show you what that looks like in our technology. So this is as if I just brought up the user interface, right? So the HER technology, it installs into its own program group. So I would go here, I would go to my HER program group, I would pull up the interface, and then when I do that, this is the screen that comes up. And then, of course, it just flipped, right? So this is the screen that comes up. The start page, right? So I can use this to quickly get started. I get some links here that point me at some documentation, at some online videos that help me get started, depending on what platform I'm using, depending maybe on the kind of topology that I want to set up. But then from there, what I do is I define a hub. And a hub is really a central point of control. A hub will always connect to a repository. So I have my demo hub defined here, and what that looks like in my case is it shows here the properties, right? So it's the repository resides in SQL Server. The database name is demo hub. It's all on the same machine. I have not checked that this database, this repository lives on a different machine. And then I did not specify username and password, which means I'm just using OS authentication to get it. So when I connect to this hub, I get access to all the definitions in this hub, which includes locations, it includes channels, and then it includes a scheduler that is running all of our jobs. Now notice that with this graphical user interface, I have access to multiple hubs, right? So from a single console, I can control a lot of environments, a lot of replication setups within the organization. Even if there's multiple hubs involved, maybe some running in Azure, maybe some running on premises. So in this demo hub, I have defined my location. So I basically went through the steps of creating a new location. So the first one that I created was Azure. But let's say that I wanted to create another location that went to an SQL database. I can optionally go through HVR running on a remote machine. And if I do that, and I'll show you in a minute how I did that for the Azure location, I can then specify this is the SSL certificate that I'm using to encrypt the data. This is the certificate that the other installation will understand. And these certificates are uniquely generated by our technology that you can use for your setup. So HR supports a multitude of technologies, and this list gives you an indication of the breadth of technologies that are supported. But if this was SQL Server, then like I said, I could have a database. I'm sure I have a database called TPCC. I could put in my user name, my password, but again, if we want to just use OS authentication, then I can use a dialog like this to set up a connection and then have a new location defined. So I already pre-created a location for Azure. I don't want you to have to see me struggle through getting IP addresses from the Azure console and things like that, and then trying to mistype my passwords, and then logging on to a SQL database in Azure with my username and equally complicated password. But I've already done this. I've already set this up. I did use the link to the SSL certificate, and I'll show you shortly where that is. If I test this connection, this goes straight into Azure, then this works, and it shows that I'm going through a remote connection that's running this version of HVR. So the SSL certificate got translated into this action. So in this case, for this particular location, I am using a remote certificate, and I have the public certificate copied from the other machine, and it resides right here, and it shows me what we're using for encryption when data gets sent into Azure. Then likewise, I have a location defined for Oracle. In the case of Oracle, I point to my virtual machine that's local to my laptop. I point to the listener port where the HR technology is running. I specify username, password, and then I specify login credentials for my Oracle database, right? So Oracle is, again, one of the technologies that HCR supports as well. And from those locations, I have then defined a channel. I've created a setup, source to target. I have included a number of tables in this list, and those tables we can get from the data dictionary, either on the source or on the destination. But when I started the destination, SQL didn't have any, it did not have any tables yet. So I started off with an empty slate on the destination side, picked up my table definitions out of Oracle. I had my source and destination set up, and then I defined through the use of actions how the data is going to flow. So the first action I created on the group source, so for this channel Oracle to Azure, on the group source, on all of the tables, what we're going to do is capture changes. And well, we have the parameters filtered down for Oracle because my location group points at Oracle. So I get all kinds of options that are relevant for Oracle. If I need help with any one of these options, then we just press the help button, and then it pulls up the the online help context sensitively to show where we are. We have all of this information available online as well, but for those who don't have an active network connection, you can actually still access the online help this way as well. Then likewise, on the destination side, on the destination group, because I point to my Azure location in this case, the certificate is relevant in this case, and then we also have an integrate action. So this integrate action is what defines how these changes are going to be sent into Azure. So this was already created. I had already run a refresh. So with the refresh, we indicate, well, what tables we want to do the initial load for, right? As an example, all of them. We want to show, we could do how many we want to do in parallel, and we could instruct this technology to create tables if they don't exist yet, and for the benefit of the replication into the table, we can create an index so that updates and deletes would be much quicker when the data goes in. So I'd already done that. I had already initialized this the CDC jobs, which are actually running here. And as we can see, there's some data flowing through the system. I can actually, from this console, I can obviously see what the current latency is. I can pull up the logs, right? So I can see what's moving through the system, right? And there's basically data moving at a pretty rapid pace through this system. But we also have this great capability where I can go into my scheduler and I can pull up statistics, which I already did, and I can look at, well, what was the load, like what was the pattern of data flowing into this machine? And I have been running this for a while. This chart looks a lot better if you have been running for a while, which I mimic essentially by starting it before the webinar starts. But as you can see here, I can move the slider around a bit. Started a little earlier today. In the beginning of the day, I had some struggles because I put a little bit too much load onto my source system, and applying that into a too small instance of SQL Azure led to a lot of latency. But then as time went on, I figured out how to fine-tune this environment. I actually also increased the DTUs on my database to get to a better latency, which then resulted, let's say, as of 8 o'clock or so, into a prettier chart that shows lower latency, right? So, of course, if I go too far out, I get these big spikes, and we no longer see the details here. Although when I hover the mouse over the screen, you can still see the details. You can still read what the latency was, but then the scale will adjust when I move this slider across. Now, this looks good. Maybe I'm interested in some other information. Maybe I want to see like how many transactions were going into the system as we were doing these runs. So we have that information available as well. We have lots of other information that we can look at, all kinds of insights that we can get into our data flows. And this is really a great capability, of course, of interest to the data integration engineers, but arguably even beyond, because it's a quick way to identify if there are any problems, and if so, where they are and what causes these. So this is a great tool to get started with that. We can split up some of these changes. We could say, well, let's look at these changes at the lower level of granularity, or if we want to see some more tables, right, details of individual tables, we just click on these buttons or click on these links to get some more information onto the screen. So I've been replicating for a while, and my machine has been using a lot of resources here. Now, one thing we always want to know when there's changes flowing through the system is, well, is our system in fact in sync, right? So if I just move this out of the way again and go and quickly run a compare, then I do want to see that between Oracle and Azure, my databases are in sync. And this is always the most one of the most exciting parts of the demo, arguably, is to validate the data just to ensure that it is in fact in sync and that we made no mistakes whilst we were taking the data out of Oracle in a heterogeneous environment, obviously, into Azure. Right, so 8 out of 9 done. Of course, the biggest table takes the longest, but hopefully that comes up as identical as well. So this is a powerful capability where in a heterogeneous environment, I can validate between a source and a destination whether my systems are in fact in sync. So, well,
Mark?
Always, yes.
Hey, it's Rob. I have a question here. On this screen, they want to know if they can save the output or print the output, or put it somewhere safe.
Yeah, so that's a great question. So in addition to this data, of course, this looks nice interactively. I can actually take a job like this, and I'll show you that in a minute, but I can actually schedule it. I get the output here, the detailed output that shows the number of rows, and it shows whether the data is identical or not. And in fact, the last one with 3 million rows or so came out as identical as well. So when I run this interactively, I would have to be careful to store that output if I want to retain it. However, if I were to run this as a schedule job, then I could determine that I want to run this, let's say, Sunday at midnight rather than just right now. I want to run this on a weekly basis, so schedule it. But then also when it gets scheduled, all of the information that the job outputs gets written to the log, and that information is then also used. It goes again back into a screen like this, where we keep track of, well, what was going on the system at any point in time. So absolutely the data can be saved, but you would want to run it as a job in that case, and not so much interactively as I just did. But yeah, that was a great question. Thanks.
We have a follow-up question, and it's when it's running the compare operation, is it simply doing row counts, or is it using the content of the data to compare it, or how is it running? What type of compare is this?
Yeah, so that's another great question. So so it might have appeared that we just did a row count, but actually we don't. So the technology, it indicates with this icon here that it's taking a checksum of the data. And of course, as we probably all know, even though the row count may be identical, if there's any byte that's different between source or destination, then the checksum comes out as different. Now, the checksum is a powerful way of doing a full data comparison, an exact data comparison based on the exact data that we have, to know whether the data is identical or not. Of course, if the row count is different, it'll always be different. But if there's anything different in the data, even with the same number of rows, the result would be that it's different. Now, the disadvantage, so the benefit, well, so to continue on the benefit of the checksum is computed in a distributed manner. So if I just quickly go back to my slide, right, so I have a copy of HER running on the machine that runs Oracle in this example, and I have a copy of HER running in Azure. Now, in this setup, is basically the copy that's running on Oracle that's computing the checksum for Oracle, and it's the copy that's running in Azure that's computing the checksum for Azure. Then the only thing that goes across the wire to the hub is the value of the checksum per table, as well as the row count. And the row count is there for reporting purposes because we know that anyway once we've computed the checksum. Now, of course, in a scenario like that, we can relatively quickly retrieve the data sets, compute the checksums, and with very little network communication, we can provide the answer whether the data is in sync or not. Now, if the data is not in sync, then we likely want more detail than just, well, your data is different, right? And maybe you see, well, there is 1 million rows on one side and there's 999,999 rows on the other side. Well, then could be that there's one row missing, but maybe there's actually 10 rows missing, and then there's 9 rows on the destination that are unaccounted for on the source. You don't know, right? So for that purpose, HER has a different mode of running a compare, which is a row by row comparison. In that case, all of the data will be brought together, and it's brought together to the right-hand side of the system. So if I would go from Oracle to Azure in this case, all of the data would be sent to the Azure side, and we would run a detailed row-by-row comparison there, and then we can tell you exactly what values were different, or which rows are missing, which rows need to be updated or deleted. If we run this in a verbose mode, we can see the exact SQL that would need to be applied to the destination in order to get the systems back in sync. Now, even when we send data across the wire, all of this data, in this particular example, we would still utilize some of the benefits that I talked about, right? Some of the tips. So maximize the bandwidth, using compression, making optimum use of the network resources, not just compressing, but also encrypting the data when it goes across the wire. It'll be encrypted, right? So all of those techniques are still applied when we do a comparison like this as well. Now, of course, in a demo like this, there's arguably never enough time to show all of the bells and whistles of the technology, but just to quickly show everyone that, well, if you have 1 billion rows in your table, you're probably not that interested in comparing all of the data every time you run a comparison. But maybe there is, let's say, a date field that indicates when the data was last modified, and maybe you would just want to do a selective comparison for the last week or the last couple of weeks based on a filter condition that indicates this is the data that we're interested in, right? So HER has a very rich set of capabilities, including filter definitions, like through this restrict action, that we can apply to a data set to manage an environment like this, right? And when you manage an environment like this, you probably also, as much as I like to show the screens and as much as I like to show the user interface, you probably also don't want to have to always look at these screens, right? So maybe you create some of these monitoring tasks that run in the background that scan the output for errors, that give you an alert if the latency exceeds a threshold that you don't want to be exceeded, and then schedule that on a regular basis, let's say every 15 minutes, and send an email if there's a problem or if there's a warning, or maybe you want to get a Slack alert when there's a warning or a problem, or if you have integration with SNMP, so if you have some system management console that integrates with SNMP, then we can also send it there. So these kinds of tasks, you can create as many as you want. You can filter this information maybe for more important, less important tasks, and then eventually basically get notified if there's a problem rather than having to monitor the environment all the time. So I know this was a pretty long-winded answer, Rob, to the question you asked, but I hope that answered the question.
Yeah, we have 2 more questions, so maybe 3. But one of the questions was really interesting. It just says, basically, do you append any additional fields to the target table during the compare process?
All right. So great question. So do we append any field to the target table when we run the comparison? We do not. So we take the exact data values, and we'll do, like in the case of in the case of my example. Let me actually go back to the slide that we're showing here. So we're going from Oracle to Azure, right? So Oracle use data types slightly differently than SQL Server or Azure or most databases, quite frankly, do. So we actually map those data types to compatible data types to make sure that we don't lose any data along the way. But then, so we do not append any data by default. By default, when we set up data integration or data replication, whether it's homogeneous or heterogeneous, the default approach of applying the changes is to keep the systems in sync, keep them identical. An insert on the source becomes an insert on the target. Update, delete, delete. That's how we, by default, apply the changes. Now, we can apply the changes differently. A couple of common scenarios are, well, on the source, I do inserts, updates, and deletes, but on the destination, I want to keep a record of all of the operations against a table. And an example of Azure Data Lake Store is actually a very good example there, because it's by no means uncommon. Customers want to just keep track of the changes against every row. So in that case, we set up what we refer to as time key apply, which means that we're going to take incremental changes and simply write out a new record for every change that indicates, oh, we made a change to this record. Of course, in a scenario like that, you want more information. You want to know whether the most recent operation on this row was an insert, an update, and a delete. So you would generally populate an extra column to indicate insert, update, or delete, and we have that information available as an environment option. Then likewise, you may want, or you probably want to know, well, like, how do I order this data, right? So you need an indication of the order of the data. Maybe you want to know the commit timestamp on the source. We have that information. So you populate extra columns to get that information. Maybe you want to know which user on the source made this change. We know that information. So you can get it as an extra field on the destination. That is, in fact, a very common scenario these days. Now, of course, then when we do a comparison, we don't look at those extra fields. We only look at the data fields that come from source and destination. In fact, you can even fine-tune the comparison if there's large values that are very compute intensive to compare, and you say, well, they're not actually that important to the business. You can even indicate to HR that you want to eliminate some of these column values as part of the comparison to optimize that process. Now, there is a third approach that is actually relatively common as well, which is to do straight replication, so insert, update, delete, but then rather than actually deleting the row on the target, is marking the row as deleted. We refer to that as a soft delete. So the soft delete will always introduce a new column on the target, let's say, and you get to name the column, but let's say you call the column is deleted. And the value of that column will simply flip when the row gets deleted on the source. And that's a powerful way to, let's say, if you have any downstream data processing happening, then your downstream data processing may actually be very interested in knowing whether a row got deleted. And rather than trying to find this out by comparing the data that is at that point in the target with the data set that came in, and doing some complicated outer join logic in order to figure that out, it's actually very convenient to know that information up front. So with that extra column that we can, again, populate by just a few clicks, we can get that information across very easily. Any other questions, Rob?
Yeah, we do. The next question is, does your software work with the IBM I server?
Great question. Does our software work with IBM I? Yes, it does. We can capture out of DB2 for I, so that's the commonly used technology on IBM I series. And there are actually quite a few of our customers that are using that technology to extract data and deliver it into a variety of destinations. Yes.
Great. The next question is, does the checksum impact the performance of the data transfer?
Okay, excellent question. So, does the checksum impact the performance of the change data capture? Now, in principle, it does not. So the checksum is based on selecting data from the source, selecting data from the destination, computing the checksum, and comparing the data. So fundamentally, that runs outside of the ongoing data replication. Now, however, whilst I say that, of course, we have, in the end, limited resources, both on the source system as well as on the destination side. And eventually, if you put enough load on those systems, well, then everything is going to get impacted. So whilst fundamentally there's no impact in computing the checksums during the comparison on the replication, of course, if we put too much load on the system, then everything is going to go slower.
Here's another question. It's a really interesting question. Are schema changes from the source applied to the target automatically?
All right, that is a great question. So HVR has support for what we referenced adapt DDL. It's an action, and I'll quickly show you where that action lives. Right, so I could do an action, and I could do adapt DDL. Adapt DDL will do exactly that. It will watch for table changes, and it provides the ability to automatically propagate those DDL changes to the destination. And this can even be done in a heterogeneous scenario. And it even works in cases like I described before, where we want to keep track of a history of changes into a row on the destination side, and we have additional columns to record more information, like what was the commit timestamp, when was it an insert, update, delete, things like that. So in those cases, it even works. Now, the DDL capture, it works on a variety of systems, including Oracle, SQL Server, DB2 on iSeries, since we asked that just now. It works on MySQL as a source as well, but it doesn't work on like all of the systems that we support, but certainly the most commonly used ones support this capability.
We have one more question here on the screen, and we may get more, but this question is, do you support data validation against data in the Azure Data Lake Store?
All right, well, that's an excellent question. So, of course, because I think this is a particularly good question, because in the Azure Data Lake Store, of course, we store data just in files, right? And HVR supports a variety of file formats that you could use. You could use Avro, you could use JSON, you could use Parquet, but actually still a lot of organizations today use CSV as well, which we do support. And then there's all the bells and whistles to determine what your CSV looks like, what's your delimiter, what's your enclosures, what's your escape character, etc., etc. Now, of course, in that case, we take data out of the comfort zone of our relational database, let's say SQL Server as an example, and we push it onto files. And typically, what these kinds of use cases will split the data on a per table basis. At that point, you're outside of the comfort zone of your SQL Server. At that point, I think trust for the end user is extremely important. So we do actually support data validation for a scenario like that. You can set up Hive on HD Inside, and we will then use that as a way to validate the data. You can also run it through Hive in some other environment, right? If you pick up a Cloudera, for example, in Azure, then we can certainly use Hive against that as well. But yes, we do support data validation against an Azure Data Lake store, and I think that's one of the areas where it's arguably mostly needed, almost more so than when it's a relational database on the source and a relational database on the destination.
We have another one, Mark.
Okay.
It's a really good question here. Is your technology available on the Azure marketplace?
Yeah, that's another good question, and yes, it is. It is on the marketplace. We are working on updating our software on the marketplace, but yes, it's already there. It's just a slightly earlier version than the one that I just showed, which is our current general availability release. But yes, we are available on the marketplace.
Mark, that's it. But a lot of great questions, right. I think. Thank you all for asking questions today.
Yeah, thanks everyone, and certainly if you'd like to talk to us or if you want to learn more, certainly do go to our website. Thank you to the PASS organization to allow us to host this webinar. This was great. Thanks, Rob.
Oh, you're welcome. I'd just like to add a few comments. First of all, thank you for coming on today. It's always a pleasure having you on. It's I get great topic, great exciting software to present. Second thing is we recorded this session and we're going to post it on our YouTube channel. So if you missed a part, you want to rewatch it, please sign in and check it out. And we have some giveaways that we're going to email out. So check your email, check your spam. You may win the prize for coming today. So thank you all very much. Oh, actually, let me see if there's any. There may be something popped up here. I think that's it. So thank you all again. Thank you, Mark.
Thank you.
I guess that's it. So everyone has a great day, and thanks for attending our chapter meeting this month, and I look forward to seeing y'all next month. Talk to y'all soon. Bye.